So the problem set 2 is rather lengthy. So we have 14 questions in number, but 2 of them have, I think, 4 or 5 questions each from the 2 textbooks of Maskell Winston Green. हाँ PDF नहीं हाँ so several problems from Maskell Winston Green and Jalen Rennie. So today I intend to do the easier ones, okay, and there are some theoretical exercises which are था तो पिछले दिन तो किया था पता नहीं मेरे नाम से तो दिख नहीं रहा कुछ न्यू करके बना लो तो रिकॉर्डिंग तो हो ही रहा है और कोई प्रॉब्लम नहीं हाँ so there are some theoretical exercises about which I am a little apprehensive that they are not done from first principles, so we will see how to do them properly. In any case, I'm pretty sure you have inherited a lot of material from your seniors. Not yet. Not yet. Yes. ठीक है ठीक ठीक हाँ पेन तो है ना यहाँ ओके Okay. So we begin with problem set 2, and the first is a set of items from Maskell Winston Green. So one is this Edgeworth box economy with locally non-satiable preferences, and X Li T is is demand for good L at P. So number one, to show that E1 summation of X1I P minus W1 plus P2 summation of X2I P minus W2 is equal to 0 for any P. Okay. So what is it saying? It's saying that the product of the prices with the corresponding aggregate excess demand functions must be equal to 0, right? Okay. So by LNS, that is local non-satiation, budget constraint must be satisfied with equality, right? At Xi P for all I, right? So do you know about this local non-satiation? Why under local non-satiation budget constraints must be satisfied with equality? No? Okay. So suppose this is your budget constraint. Okay. And preferences are locally non-satiated. Suppose at the equilibrium demand, the equilibrium demand is not on the budget line. Okay, then the only other possibility that it is an interior point in the budget set. But if it is an interior point of the budget set, then local non-satiation, what does it say? It says that there exists for every epsilon neighborhood of any bundle, there exists for every epsilon neighborhood for every bundle, there are points in that neighborhood which are strictly preferred to that bundle, right? So if this bundle is in the interior of the budget set, then notice that I have drawn a ball around this particular dot, right? So call it the B epsilon ball of radius epsilon. Okay, I can find a radius epsilon for which there exists a point, there exists another bundle X prime, which is inside the budget set, right? But is strictly preferred over this point. So then X, which is the demanded bundle, cannot be an optimum, right? So we can write, so otherwise there exists X prime I in B epsilon XIP such that Xi prime is strictly preferred over XIP, and XI prime is in the budget set, right? Okay, so there will be a contradiction with LNS if the demanded bundle is not on the budget line, right? Okay, so therefore from here what do we have? So therefore for every I, P1 X1 IP plus P2 X2 IP must be equal to P1 W1I plus P2 W2I. This is the budget constant. Okay. So this is for I is equal to 1, 2. Right? For both the agents, it must be true. Now call the expression for I is equal to 1, 1, and call the expression for I is equal to 2, 2. Okay. Then 1 plus 2 will give you the result. Make sense? Okay. Okay. And then you have from here Walras law. So part B wants us to argue that if market for good 1 clears at P star, which is, so this symbol is for all components of the vector P star being strictly greater than 0. Okay. Then so does market for good 2. Now the argument is clear from here. Okay. So if market for good 1 clears at prices which are strictly positive, then it means that P1 times this term must be equal to 0. These things are identically 0 and multiplied with strictly positive prices, this vector product, the scalar is equal to 0, right? So now let's look at this component, this part. Okay, so this is because we are assuming that market for good 1 clears. So the summation of demand for in market 1 must be equal to endowment of market 1, total supply in market 1, right? Okay. So therefore this must also be equal to 0, right? But if this is equal to 0, and I have assumed that P2 is greater than 0 as well, because P star, okay, so now therefore market 2, so if this is positive, if this is strictly positive and multiplication with this is 0, then the term within brackets must also be equal to 0, right? Okay. That's question 15.b.1. So this is useful, and you should try to extend it from the 2 good economy to n good economy. Okay, and with multiple agents as well. Okay. Okay. Second question. So you have a 2 by 2 economy with Cobb-Douglas preferences. Acha, so when you are doing general equilibrium questions in the exam, okay, it's better to remember by heart some of the demand functions of for the specific preferences, particularly Cobb-Douglas, linear, Leontief, Max, the usual ones, the usual culprits. So 2 by 2 economy with Cobb-Douglas preferences. So here, because demands are Cobb-Douglas, so what I am the question essentially asks you to find is there are 2 consumers with Cobb-Douglas preferences, and their Cobb-Douglas coefficients are alpha and beta. So one consumer has preference x1 to the power alpha times x2 to the power 1 minus alpha, and the other one has preference x1 to the power beta and x2 to the power 1 minus beta. Right? So for this economy, you have to find out that how the equilibrium prices and quantities will be affected by a change in the endowment of agent 1. Okay, so that is omega 1,1. Okay, so this question is kind of this is totally calculation based, but this question is repeated in a somewhat different form in question 5 of the problem set. Okay, so it's enough. So if we do this, I mean, if I give you enough hints to do this, then we don't have to do question 5. So let's see. So X11P, demand for good 1 by person 1. So what is that? Because his Cobb-Douglas coefficient is alpha, his wealth is this, okay, and price of good 1 is P1. Okay. Similarly, you can find out X12. Okay, so for X12, you will just replace this with beta, right? And you will replace omega 1,1 and omega 2,1 with omega 1,2 and omega 2,2. Okay. And similarly, you will find out X21, so which will be 1 minus alpha of this, okay, and X22, which will be 1 minus beta of the corresponding thing for agent 2. Okay. Now comes a little bit of a tedious part. So because it's a Walrasian equilibrium, markets must clear, right? So you should have X11P plus X12P is equal to omega 1,1 plus omega 1,2. and x21 t plus x22 t must be equal to omega 21 plus omega 22. Solve them simultaneously to find T1 and T2, right? And as you know by now, there are some indeterminacies in calculating Walrasian equilibrium because demand functions are homogeneous of degree 1 in prices, right? So here yeah, so here you can take one of the prices to be 1 and the other price to be just P2 or something. So take P1 is equal to 1 and P2 is equal to P2. Okay. So then you can solve for this easily and you will get a ratio of equilibrium price ratio. Okay. Now you substitute them back into the demand functions which are calculated above to find out the equilibrium allocation as well. Okay. Now your task is straightforward. Differentiate them with respect to omega 11 to find out which direction it takes. So we should have something like as follows. So del P1, P2, del 11 must be negative. So that is understandable because there is excess, there is more supply in the market of good 1, right? So the price of that should decrease relative to price of good 2. Okay. And because there is additional endowment with person 1, okay, so his and Cobb-Douglas preferences are normal, right? Cobb-Douglas preferences are normal. So therefore, del x11 del omega 11 is greater than 0, del x21 del omega 11 should be greater than 0, right? Individual one's income has increased, he can now purchase more of both the goods. Okay. Similarly, for the other person, notice that because there is additional amount of good 1 in market of good 1, he can possibly buy more x1 as well. So therefore, I should see but in the other market, okay, the amount of good 2 remains constant, right? There is no change there. So therefore, we should have del x22 del omega 11. Why? Because this guy's demand for good 2 is increasing and there is a constant amount of good 2 in the market, right? So in order to balance out this, so what I have not done here is the explicit calculation of these derivatives. So this is for you to check that these derivatives. So let me tell you, this will be tedious expressions, pretty long ones. Huh? Huh. Exactly, that's what I said. Huh, huh. So that's always the way to go. I mean, uh, the mark. So what do you mean by equilibrium price ratio? Is the market clearing price, right? Market clearing prices mean you calculate the demand functions, equate it with supply, and find out the prices at which the market clears. Okay. A good thing is that if you have several markets, well, more than one, you have to calculate only prices for n minus 1 by Walras law, the previous exercise. Okay. Oh, because the guy one's demand for good 2 is increasing at higher income. Okay. And there is a constant amount of good 2 in the market. Okay. So his demand must decrease. I mean, when I say demand, I mean his purchase. Okay. And the guy one is now also loaded with cash. Okay. He has more purchasing power. So he can purchase more amount at omega with with higher endowment and less price of good one. Okay. Hmm. So because there is more amount now in this market. X1, there is more supply in the market. Okay. And there is at for these preferences, for these Cobb Douglas preferences, there is enough for both to increase with the additional supply. So person one gets a little bit of the additional endowment. Okay. And he can also use some of the additional endowment that he has to purchase additional amounts of good 2. Person 2 cannot purchase additional amount of good 2 because there isn't any. Okay. So, but because there is additional supply of good 1, he can purchase a little more. And because also the price of good 1 has decreased. There are several effects here, right? Well, so the total amount of the endowment has increased, but the major impact for person 2 is that the price of good 1 will decrease. Okay. So you can, ideally you should check for, I mean, whether you have done it for the first part or not, you can also check with what will be the income effect and the substitution effect. Okay. So you can separate out these two and check that, okay, person 2 does not have any change in his income, right? Okay. So his is purely substitution effect. So because the price of good 1 has decreased, okay, so he can purchase more of good 1. Right. Compared to the first individual. Ha. Right. Right. So for these preferences, Cobb Douglas preferences, you can explicitly calculate the income effect and the substitution effect and check the corresponding amounts for each of the agents. Question 5, on the other hand, asks you to find out welfare changes. Right? How to do that? How will check for welfare? Through indirect utility functions. Okay. check whether the value of the indirect utility function is that changing and how much it is changing. Okay. Okay. Now 15.b.3. To argue graphically that in an Edgeworth box economy with local non-satiation, Walrasian equilibrium is Pareto optimal. Okay. How to do that? So suppose you have an Walrasian equilibrium. This is your endowment point. Okay. And this is your equilibrium. So this is your equilibrium. Okay. So with local non-satiated preferences, why should this point be Pareto optimal? It's a very simple argument, but the argument can be clearly seen in the picture as well. How? Sorry? Yeah. But remaining on the budget line is not the issue with Pareto optimality. Pareto optimality has nothing to do with prices. Huh? Core? No, we are not talking about core here. We are only talking about Pareto optimality. Okay. We are only talking about Pareto optimality. We are arguing that the Walrasian equilibrium, which is given by this tangency point with the budget line, this must be Pareto optimal. So what is Pareto optimality? That no agent can be made better off without making somebody worse off. Well, if I have to make agent 1 better off, strictly better off, then I have to go here, right? And the strict upper contour set, that is the set of all bundles which are strictly preferred to this point, okay, lie in the interior of this indifference curve, right? And it is detached from this line, this point. Right? Similarly, for agent 2 as well, these things follow, but in the other direction. Right? So you cannot make any agent better off without making somebody worse off. Okay. So only at this point, I don't have to explicitly argue about this thing. I have to just say that this point is Pareto optimal. Okay. So I cannot find another allocation, okay, where agent 1 or agent 2 is strictly better off and the other agent is not worse off. Okay. So the notice here that the not worse off points is the weak upper contour set. So that is this set for agent 2, it's this set along with the boundary. Okay. And for and the strict upper contour set of agent 1, where he is strictly better off, is the interior of this indifference curve without the boundary, right? And because the boundaries are tangent at the Walrasian equilibrium, so these two sets are disjoint. That's your argument for Pareto optimality for this Walrasian equilibrium. Huh. Yeah, yeah. Okay. 15.b.4 is kind of technical, so I will skip it for the time being. So there you have to essentially draw some diagrams, but also have to make some, argue about some proofs. So I will come back to it in the next class if time permits. Okay. But this is something that you can verify, that 15.b.4 says it talks about two properties. One is a gross substitute property and the other is a normal property for the offer curve. Okay. So first it tells you to draw an offer curve satisfying the gross substitute property. Okay. So gross substitute property just said that uh, if the price of one good increases, okay, then the demand of that good must decrease and the demand for the other good must increase. Okay. So thus you will get a certain shape of the offer curve. It will lie above all indifference curves in the upper contour set of indifference curves tangent to the endowment point. And then you have to argue that offer curves with gross substitute property can intersect only once, and then how many times this offer curves having normal and GS property can they intersect, can they not intersect. So there are arguments about this. So that is something that we will discuss in more detail. I am somewhat not so satisfied with one of the proofs which seems like too complicated, doing too many things. So we will come back to this later on. But well, try to draw these curves. So what you just have to do is the following. So for instance, for normal, so what is normal telling you? Normal telling you that suppose you have a particular point like this, which is your demanded bundle, and if price of that particular commodity is increasing and the price of the other commodity remains the same, so then uh, you should go like this. Okay, so if this is the demanded bundle for P1, where P1 represents a lower price of good 1, then this will be the demanded bundle at P2, where P2 represents a lower and higher price for good 1. Okay. So now draw these things carefully. So if this is the budget line for the first one, this is the budget line for the second one. Okay. They must pass through this endowment point, and you should have indifference curves like this. So your offer curve goes like this. Okay. So this is becoming too black. Draw it, in a spacious manner. So then it should be fine. Okay. Similarly for gross substitute properties and so on. So in normal. So normal says that if the price of a good increases, then the demand for that good will increase if only if the demand for the other good also increases. Okay. So then you should have, find these points carefully and then draw the corresponding budget lines, indifference curve, tangency points, connect the equilibrium points to get your offer curve and so on. Okay, so you should be able to do these things. One of the tasks is that when a normal offer curve intersect several times, that's easy. Okay, so that's about 15.B.1 to 15.B.4. Okay, so this is something I had. This is problem 5.10 from Jell and Rennie. And I spoke about it in the last tutorial as well. In a 2% too good exchange economy with strictly increasing utility functions, it is easy to see that an allocation is Pareto efficient if and only if it solves the following problem. Prove that X bar in FE is Pareto efficient if and only if it's saying that an allocation in the Edgeworth box FE is Pareto efficient if and only if X bar I, so X bar I is essentially the allocation for agent I. Okay, so this is X11, X21. Okay, it solves this problem. Maximize the utility of agent I subject to the other person's utility remaining at the level of xj bar, okay, subject to the resource constant. Okay, so can you tell me why this equivalent should be true, why this one should be Pareto efficient and vice versa? Suppose X bar I solves this problem, then why should it be Pareto efficient? Exactly. And what's the converse? Uh, okay, to make the proof smooth, why don't you use contradiction? Okay. Suppose an allocation satisfies Pareto efficiency, but is not a solution to this problem. Okay. Then it's immediate. So then there exists another feasible allocation. Notice that this is just the feasibility condition, right? The second one, these two are the feasibility conditions, right? So there exists a feasible condition, a feasible allocation, which gives at least as much utility to agent, one of the agents, and higher utility to another agent. Okay, so therefore it cannot be Pareto efficient. Okay. Okay. So then it asks you to generalize this equivalent definition of a Pareto efficient allocation rule to the case of n goods and I consumer. N goods is easy, right? For n goods, you will have n feasibility constants, and xi's are, rather than pairs, these are n vectors. What about n consumers? If you have n consumers, what will be the relevant maximization exercise? Of course, which constants are there? Okay, so there are n minus 1. Okay, so there are n minus 1 other constants for the consumers apart from the feasibility constants. Okay. Five point 11 is easy. Utility functions are given. Endowments are given. So you are asked to characterize the set of Pareto efficient allocations. Use this method. Characterize the core of this economy. So because it's a too good 2 by 2 problem, you have to find out the endowment utilities and add those constants to the Pareto efficiency constants. Okay. C asks you to find a Walrasian equilibrium and compute the Walrasian equilibrium allocation. That's also straightforward. We have done that previously. Verify that the Walrasian equilibrium you found in part C is in the core. Verify. Okay. 5.14 has a n good Cobb-Douglas utility functions with multiple consumers and so on. So this is just making things a little bit cumbersome, but for your purpose, use the 2 by 2 case. Okay. And what you have to show that no consumers utility function is strongly increasing in Rn plus, so that one cannot apply some theorem which is given in Gell and Rennie. So if you have strongly increasing utility function, then there is one existence theorem. And if you have some other conditions fulfilled, then you have another existence theorem. You just have to check that Cobb-Douglas preferences does not satisfy the conditions of the first theorem, but satisfies the conditions of the second. Okay. 5.17. There is 5.15 as well. Okay, there are 100 units of X1 and 100 units of X2. Consumers 1 and 2 are each endowed with 50 units of each good. Consumer 1 says, I love X1, but I can take or leave X2. Consumer 2 says, I love X2, but I can take or leave X1. Draw an Edgeworth box for these traders and sketch their preferences. Identify the core of this economy and find all Walrasian equilibria for this economy. So how do you do this? So how would the indifference curves look like? Consumer 1 prefers X1 but is indifferent with respect to quantities of X2. Yes. Hmm? Okay. Similarly for person 2 as well. Okay. So there is some okay, identify the core of this economy. So let us say, so this is 50-50. How do I find the price ratio? So what are the demand functions? So U1 of X1, X2 is X1. U2 of X1, X2 is X2. Okay. And the demands are given, sorry, and the endowments are given. Prices of good 1 and good 2 are given. I substitute it. What should I get? Do I get a demand function? So let's do it for one of the consumers. So U1 of X1, X2, right. Yeah. So that's your Walrasian equilibrium. Okay. And Are all Walrasian equilibrium in the core? No. So the core must involve all those Walrasian equilibria which give both the consumers at least 50, right? At least 50. Yeah. Okay. So this should be easy to solve. Okay. Right. Yeah. So okay. So endowment will be the core. Yeah. Endowment is in the core for sure. The endowment point is surely in the core. Right. Hmm. 100, 0 and 0, 100. Well, okay. But if I do that, does this mean that the core is empty? Huh? Hmm. Right. 100, 100. Okay. So this, yeah. Right. Okay. So core consists of a single point. Now, if you no, so okay. So if this is Walrasian equilibrium, okay. So the preferences are locally non-satiated. Okay. So this is Pareto optimal. Okay. If this is Pareto optimal and both the agents get more than their endowment utilities, okay, so then this point is in the core, right? the corresponding utilities are 100. Can any agent break away from this coalition and get higher utility? So then this is the only possible call, right? So then this is Walrasian equilibrium. This is the Pareto efficient allocation. Yeah, so this gives you 100, the maximum possible utility that you can get. There does not exist another allocation. Core is a subset of Pareto optimum. Good. Okay. So okay. Question 3, consider a 2% too good pure exchange economy. Goods are X and Y. Utility functions are very standard, X1 square Y1, X2 Y2. Okay, so these are both Cobb-Douglas preferences, and you have to find out initial endowments are given, assuming T1 is equal to 1, compute competitive equilibrium. Straightforward exercise. Consider 2% too goods exchange economy. Goods are X and Y, utility functions are given. Utility functions are X1, Y1 and X2 plus Y2. So you can find out the demand functions accordingly. And the initial endowments are given. For this economy, find out competitive equilibria and price, and draw the equilibrium allocation in the Edgeworth box. Consider the allocation, some Z1, Z2 is given. Find out if this allocation is Pareto optimal. So you have to check whether the utilities are maximized and market clearing conditions are satisfied. And then find out the transfer payments T1, T2 such that T1 plus T2 equal to 0, and the allocation Z1 and Z2, which is given in the previous question, is a competitive equilibrium with transfer. So the question actually gives you a hint that the earlier allocation must be Pareto optimal. Okay. So if that is the case, so what do you have to do? You just have to find out, you have to plug in T1 and T2 in the demand functions appropriately. Okay. And check that, you will have two different equations, and you have to find out T1, T2 such that you are able to implement this particular allocation. Okay. Again, straightforward exercise. I think we have done something similar in the previous problem set as well. Right? Okay. Question 5 is a repeat of this Cobb-Douglas economies. And now instead of finding the price and allocation, you have to find out welfare. Okay. Consider the economy as in the above question. Suppose alpha equal to beta is equal division of endowment between the individuals necessarily a Pareto optimum allocation? No. What is it? If both individuals have identical preferences and but their endowments are different, possibly. Okay, will they have will there be equal deviation of endowment between the two agents? Equal division of endowment? Not necessarily. So find an example where this is not true. Does equal division of endowment among the individuals constitute a Pareto optimal allocation in general? No. Again, drop an example. So whenever you find such a question, drop an example. Okay, so this is interesting. I like this problem. So consider the 3x3 pure exchange economy. There are three goods X, Y, and Z, and individual demand function, individual utility functions are following. I like this question very much. So these utility functions are given and the initial endowments are given. Initial endowments are equal for all the three agents and they involve 1 unit of every good. Okay? Yeah. Yeah, I noticed it this morning only and I forgot to change it. But okay, here is something nice. Why don't you do that for that problem as well? Okay. So in that case, there is a pure externality on agent 3. Okay, of the actions of agent 1. Positive externality. Okay. So if that is the case, because there is a positive externality at the Walrasian equilibrium will not be Pareto optimal because there is externalities, right? Right? Because the Walrasian equilibrium depends on private decisions, because additional amount of consumption for agent 1 would imply greater welfare for agent 3. Okay, so at a Walrasian equilibrium cannot be Pareto optimal because it involves less welfare potentially for person 3 rather than what it should be. Okay, acha. So now the question is the following: given this, do initial endowments constitute an equal division allocation? Yes. Do they constitute a non-envious allocation? Answer is yes. Everybody's utility is 6 at every other's allocation as well. Okay. Does it constitute a Pareto efficient allocation? No, how? And is this in the code? Huh? Right. Okay. So you have 3 units of every good, right? So now notice, uh, so I did not use his example, but I use the following. So let us keep agent 3 at 111. Okay. Now we have 2 units for of every good for the other 2 agents. Okay. Keep so okay. Keep the y good same 1 1. Okay. Give 2 units of good 1 good x to agent 1 and 2 units of good z to agent 2. Okay. And agent 1 gets 0 units of z and 2 units of x. Yeah. So that will give you that you can improve the utility of 2 agents, okay, keeping the welfare of the other person at the same level. So immediately it follows, right? For core, it's fine if you are able to show just one coalition, huh? Even if it is like one single person. So in this case, you cannot show a deviation for one single person. You have to show for either 2 or 3. So here is a 2% coalition deviation. Okay, rest of the stuff will next week. Yeah. Oh, suppose an allocation is Pareto efficient, but it does not satisfy this optimization problem. Okay. So there, because it does not satisfy that optimization problem, so then it means that there is a feasible solution which gives higher utility to agent 1 if that's the one whose utility you are maximizing. Exactly. And this is very important when answering your questions in the exam as well. Okay. Never write more than what is necessary. Okay. Because the exams are going to be, lengthy and I don't know what. So, never write more than what is necessary, but not less than that. Okay. Yeah. There's a question about diagrammatically why always Mhm. With local non-session. Yes, yes. In that case, I mentioned it because I thought these two inputs of the tablet to each other. There is no core allocation because the left is not there, so there is no core as well. Oh. It itself says that there is no better allocation and hence this is and we say there is no core. No, why would you argue in that way? I mean, what if the endowment point was your Walrasian equilibrium? Hmm. 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 Oh, but I mean, it's unnecessarily argue with the definition. Always use the first principle definition that you have learned and apply it immediately. Hmm. Hmm. So he can obviously demand more of good two also. No, person two, no. Person two's case is the following. Person one's uh, endowment is increasing of good one, right? Now we see in the beginning that price of good one is dropping, okay, and also there is because of more availability of good one and increase in his real income. This is important because you have normal preferences here. So agent one can consume higher amounts of both good one and good two. Now notice that there is no change, there is as such no change in the endowment of person 2. W12 remains the same, W22 also remains the same, okay. Price of good one decreases, so therefore his income is gross income is decreasing, okay, because good one has become cheaper, he can afford more of it, but it can come only at the expense of reducing his consumption of good two, because there is he does not have any substitute, he does not have any income effect per se, okay, apart from a little bit of a change in the price of good one in the equilibrium, okay. The main change in his thing is coming from substitution. Good one has become cheaper, so let's purchase more of good one at the expense of good two. So that's why I said that it's probably instructive to calculate at this point, and because you will be in your final, you will also be appearing for part one, to calculate the income effect and substitution effect for these preferences as well. So as omega 11 changes, what is the impact of corresponding to income effect, and what is the impact corresponding to substitution effect? Okay. Yeah, so here it's not just share of good one, okay, it's the absolute amount of good one and under the ownership of person one, that's increasing, okay. uh. 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 Uh-huh. Right. Oh, this is the same actually. Okay, so the if you want to try it out to understand it, so treat the first sum of x1 and y1 as one good, okay, and z1 is a second good. You know the substitutability between good one and good two, right? So treat 3x1 plus 2y1 as some other good, w1, okay. You will get a lot of cases, okay. Work them out, you will figure out how to do it, and finally it will look somewhat like the same things. We know that the demands for these cases are W upon minimum of P1, P2, right? So it will be something like that as well. Okay. Yes, sir. Yeah, yeah. Preferences are fixed. No, I don't know. So, no. For instance, what if you had this? So there is a question on quasi-linear preferences. Okay, and in quasi, thank you. Bye. So quasi-linear preferences, we know that uh, the set of Pareto efficient allocation lie on a straight line horizontal to the x-axis. So we don't know. I mean, uh, स्क्वायर भी था कि नहीं पहले पता नहीं था और रेक्टेंगल से और डिफरेंट रेक्टेंगल हो गया ऐसे बोलते हैं हाँ रेक्टेंगल एज लॉन्ग एज यू से दैट स्क्वायर इज आल्सो अ रेक्टेंगल right so there was a rectangle and now there is a different rectangle. It will be difficult because diagrammatically you may mess up with preferences, right? Okay, so notice that this is what is going to come up in that 15.b.4. The offer curves of gross substitute and normal demand is going to look very similar. Okay, but they're not. Uh, 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 right. Yeah, we have a proof, but I'm trying to, simply. So now all those things are fine. I mean, for them, but we should have a. No, but we are drawing it that way, right? We are not using the preferences as such. So if we use, so it must follow from the preference structure itself, and given the other assumption, which is monotonicity and convexity. Right. No, so that's what I'm trying to understand as well. I mean, it has to be some kind of contradiction argument. That suppose it is not, suppose they don't lie on a straight line, which is horizontal to the axis. Okay, horizontal or vertical, whatever. So, if that is not the case, then there must be a violation of either of the convexity or this monotonicity assumption. Yeah, I mean, if I take 2 points, of course, I can make 2 points lie on a straight line, but this requires a little more. So, I mean, it cannot be a line which is horizontal to the one of the axis. That's what I require. Mm. Well, that will be pushing it too much. But I mean, the way to understand these proofs are, they will violate one of the conditions that is given for regularity, right? Sure, sure. Huh. Huh. Hmm. No, I have to look at that. I mean, there are many proofs of this theorem. They are, I mean, kind of staple diet for people who work in general equilibrium. Uh, we'll check. Sure, sure, sure. Anytime. Hmm. I mean, that makes more sense to me. I mean, rather than looking at, weak axiom and all these kinds of things, that doesn't make much sense to me. I will see.